Okay, we're still looking at the essential questions of how you can graph a system of linear inequalities. Now, last time we saw how you could check the answer, but we really didn't see how to find the answer. We didn't actually do any graphing, so let's do that this time. So in order to graph, we want to find something that is will give us a solution to, well, let me phrase that differently. You want to find all the solutions to the system, not just one. There's a whole bunch of range and domain that would be an answer. So let's look at this really carefully. Graphing a system of linear inequalities, you want to graph each inequality in the same coordinate plane. So in this case, they graphed y is less than x plus 2. They also graphed y is greater than or equal to 2x minus 1 in the same coordinate plane. Then you want to find the intersection of the half planes. So this one right here is split into two halves, and each a half plane and a half plane. And this inequality line here is split into two half planes. And the intersections where they meet in the middle. And that's all the solutions, all the answers for these two inequalities. So for instance, this would be an answer, or this point. So a 0 and 0 would be an answer, but also 0, 1 would also be an answer. There's a lot of right answers. We want to represent all the solutions. This intersection is the graph of the system. So this intersection where these two lines are both true is all the solutions, all the answers for the inequalities. Okay, so let's go ahead and graph the system of inequalities. Let's do an example and see what we get here. I went ahead and rewrote the question on a larger coordinate plane so that it's easier to see the graph. So the first one, and I do want you to take notes on this, so call this notes. 5.7b. Okay, so the first one is y is less than or equal to 3. So we go up to 3, start the origin, always 1, 2, 3. And then draw your line through it. And notice that it is less than or equal to. So we do a solid line. Good. And then the second inequality is y is greater than or equal to, or sorry, y is greater than x plus 2. So the m would be 1, and the b would be 2. So we'll start at the origin, count up 2 for the b equal 2, and then we'll rise 1, go over 1. Up 1 over 1, up 1 over 1. And if you want to, you can go the other way. I like to do that so my line is a little bit straighter. When I'm not using rulers, it helps to have a little, lots of lines. Yeah, there's the announcements if you can hear them. Okay, so we have both of these lines or inequalities are represented now. Now we need to do the test point and see what's true for them. And so I will use 0, 0 as my test point. I'll substitute a 0 for the y. Is 0 less than or equal to 3? Yeah, 0 is less than 3. So that means that that's a true statement. So this 0, 0 is true. It's not lying. So everything under that is also true. If down is true, everything down of it is true. So all this is the solution for this inequality. Now, let's look at the second one. We'll try the same numbers, 0, 0, and see if it's true for this one. So 0 for the y. Is 0 greater than 0 for the x, x plus 2. So is 0 greater than 2? Well, no. Actually, 0 is not greater than 2. So for this black line here, we see that this 0, 0 test point is false. It's lying. It's not true. So I can't shade in that part. I have to shade in the other half plane. So I'll shade it in this side. So what we see emerges here is the solution is going to be where they both are shaded. So in this case, anything where they're both shaded right here would be a solution. Any number in that point would be true. So let's just choose one. If I were to choose like a -1, 2, 3, a -3 and a 1. Well, would that be a solution? I could test it really quick by substituting these in, and I'll see that a -3 for the y is less than or equal to 3. It works. We can substitute in here. A -3 is I'm sorry, a 1 for the y. Let's write it. Is greater than, for the x, you put in a -3 plus 2. A -3 plus 2 would be a -1. Yeah, 1 is greater than 1. So this shows that it is one of the many solutions to both of these inequalities through the test point. Okay, let's do another example. Hopefully we won't get any interruptions. So let's graph these. Now, I'm really tempted to do the intercepts on this one. Just it's set up so nice for it, but I'm not going to because I already know the answer and there's something I want to illustrate. So I'm going to go ahead and find the y and the b again. So in order to do that, I have to do a little bit of manipulating of the equation to solve for y. So I'm going to do a -2x to both sides. So you'd have y is less than -2x minus 1. And this one, I do a -2x also on both sides. You'd have y is greater than -2x plus 3. And we see the m is a -2 over 1. And the b is a -1. And the m is a -2 over 1. And the b is 3. And some of you might already be able to detect the answer, but let's go ahead and graph it and see what we get. So for this one, b is a -1, and I would go down 2 over 1 for the slope, down 2 over 1, down 2 over 1. I'll just go the other way, up 2 over 1, up 2 over 1. Okay, let me draw. Now, as my line, I put equals, but actually it says less than. So my line's going to be jagged, right? It's not going to be a continuous line, because it's is less than. Okay, but on this one, should be is greater than. I start at 3. I'm going to use a different color marker here. Starting at the origin, go up to 3, 1, 2, 3, and then I would go down 2 over 1. So down 2 over 1, down 2 over 1, down 2 over 1. All right, and let's see what we get here. Actually, it's a jagged line as well because this is greater than, not as greater than or equal to. Okay, and so what I observe is these lines are parallel, right? They're parallel. They have the same m's but different b's. So we might have been able to detect that from the beginning. And so looking at this, we want to do our test point still. I'm going to choose 0, 0 again just because that's an easy test point to see what side to shade in. So 0 for the y is less than a -2 times 0 minus 1. So is 0 less than -1? No, that's false. So this 0, 0 is false. So I would shade in the other side. Because this side's not true, I would shade in the other side, so the downside would get shaded. And now let's do the other test point. We'll substitute in a 0, 0 again. Is 0 for the y greater than -2 times 0 for the x plus 3? Is 0 greater than 3? 0 is not greater than 3. So this is also not true. So I would shade in, if the bottom side of this line is not true, you shade in the top. So you see that they have no overlapping area, right? And so the answer is no solution. Go ahead and try it on your own. Write this in your notes. If you need to rewatch the video, you can. In your journals, try 3, 4, and 5.